Good afternoon. Welcome to CSIS. My name is Jim Lewis. Thanks for coming to our event here. We have a great set of speakers today. I'm going to read their bios. The format will be, first we'll hear from Thomas Carl, then we'll have the panel members speak, and then we'll take questions and answers for the audience for as much time as we have left, which should be enough to get some good discussion. So I'm looking forward to hearing today's presentations. I'm glad you could make it out in the semi-tropical weather here in Washington. Let me do some quick bios, and I should note that the full biographies of the speakers are on our website. So if you go there, they're just too long to read, as you might expect with such a distinguished group. Thomas Carl is currently the director of the National Climatic Data Center at NOAA and the chair of the Subcommittee on Global Change Research. So he's perfect, and he'll be doing our keynote presentation. Jack Kay is the Associate Director of the Research and Analysis Program of the Earth-Sun System Division at NASA's Science Mission Directorate, and he serves as a member of the Steering Committee for the Global Climate Observation System. Anna Unra Cohen, who we're glad you could make it. We're glad for two reasons. Not only was traffic slow, but if anything had gone wrong today down in the Gulf, Anna would have had to bail out. So far, so good. She's the Deputy Staff Director of the House Select Committee on Energy Independence and Global Warming, and began working for Chairman Markey in 2001 as a Science and Technology Policy Fellow, and of course was at the Center for American Progress for a few years. And finally, we have Dr. Johannes Loschnig, who's a Senior Policy Analyst at the White House at OSTP in the Energy and Environment Division. He's worked at NASA and as a staff director for the House Subcommittee on Space and Aeronautics. So a very full panel. I think we're going to have a very rich discussion. With that, let me turn it over to Tom, please.
Thanks, Jim. And thank you very much for inviting me here today to talk about climate services in general, and I'm going to focus on NOAA's notion of how we're thinking about a climate service, recognizing there is other discussions going on with respect to a national climate service, and we're trying to self-organize to see how we best fit in that national picture. And so I'll share with you some of our thoughts as we've put them together to date. When you begin to think about some of the motivations for a climate service, one of the things you certainly want to begin to think about is, what's your vision for what a climate service is? And one of the things you recognize when you begin to talk about a climate service, first part of the discussion, people say, yeah, that seems like a good idea, and everyone has a different notion of what a climate service is. So as you begin to talk a little bit further, it begins to evolve and recognizing, well, it's not exactly the vision that I had. So what we tried to do is put together collectively some of the thoughts within NOAA in terms of what a climate service might look like in NOAA. And in terms of a vision, what is it that we would hope to accomplish? Well, we'd like to get a society who's really informed and actually anticipating and responding to climate and its impacts. And so when we say climate, we mean both climate variability and climate change. And in terms of trying to focus a little, zeroing in a little bit more with respect to what a mission of a climate service be in NOAA. And we feel it's important to mention the word understanding, improve understanding. And again, you'll see the word anticipation of changes in climate, but not just for the sake of understanding changes in climate, to do that in service of a resilient society and environment. So there's a recognition that there's a purpose for what we're trying to do, and it's really driven by the needs of society to live effectively in the environment we have, both the natural environment and the built environment. And we also are thinking there's a number of objectives that we would try to put together, and some of these have to do with improved communications. We've got a NOAA Next Generation Strategic Plan, things like communications, improving communications, as I mentioned, improving understanding, being able to predict climate into the future, and be able to assess climate in terms of the changes we've seen, and be able to provide information that will enable either organizations, individuals, states, municipalities to help in decision making. But there's a number of challenges when you think about a climate service. First challenge is that the science and the notion of the services are really rapidly evolving. So you're trying to develop a concept here, and quite frankly, I think the community is still trying to come to grips with what exactly we mean here and how these things interplay. So that's a challenge. Another challenge is we certainly want to strengthen science because we know there's a number of uncertainties we still don't understand. We want to reduce those uncertainties, but we recognize there's growing demand for delivering services now. People need to make decisions now. That is a challenge, how to balance that. Partnerships and dependencies, recognizing that the problems that we're addressing today, very few of those can be addressed within any given agency. So partnerships become extremely important. And then recognizing there's limits to what any agency can do. There's fiscal accountability. And so those are other issues that need to be addressed in some kind of a strategy for a climate service. We use assessments as an important tool, and you'll see that later on as an important tool of our strategy for a climate service. And recognizing when you do an assessment, and I'll talk a little bit how we're thinking about assessments, those are activities that are often shared. They're usually not done exclusively by one agency. Balancing users pull and science push. And what here we're referring to is we recognize that we want to be responsible to user needs, but the science itself can't be driven by simply what's needed to make a specific decision. There needs to be longer term investments. And a good example where the synergy takes place might be, it was a number of years ago, scientists discovered the ozone hole in Antarctica and the stratosphere. And prior to discovery of the ozone hole, there weren't any demands for products about potential effects of ultraviolet radiation and what are the levels of UV and potential skin cancer, what's the size of the ozone hole, having these products available regularly every year and updates. There wasn't a demand for that until scientists discovered the ozone hole. So sometimes science has the lead, and then sometimes users have the lead in terms of what they need. Clearly, traceability, credibility, transparency, extremely important. We've seen in the press a lot of concern about transparency and open access to data. Clearly, if we're going to have credibility, that has to be a key part of any kind of a climate service. Within NOAA, we recognize there has to be some changes in our own internal culture. We've been an agency in climate where we have provided, we think, some services, but heavily based on lots of research. The U.S. Global Climate Research Program Act in 1990, we've done a lot of work trying to understand climate. Now the recognition that climate is changing, decisions need to be made. This actually is a different way, a different environment, and the old way of going and waiting a few years for the best science to come forward. People are trying to make decisions in real time. So that's a different culture. And this notion of evolutionary, not revolutionary. Whatever we're going to do in terms of helping to better organize ourselves, clearly we may have some revolutionary concepts, and some people may think of them as that. But in terms of progress, in terms of making a huge change, it's more likely to be incremental and not a complete change and revolution. Let's see if I go to the right way here. What we are thinking about from our perspective is that we have a number of core capabilities in the agency. And we see these core capabilities as the key components to actually meet the growing demands by society for decisions. The way we've been integrated observations, data stewardship, monitoring, research and modeling, and then something we call interactive services. And so this isn't kind of the loading dock mentality where here's our products, come and get them, but it's trying to understand what users' needs are in an interactive, ongoing dialogue that is two-way. One of the things, if you look at these core capabilities, you are immediately challenged, well, how would you define whether or not you could manage such a thing and whether it would be successful? And one of the things that we've talked about is that we would not want to judge our success by saying, we've scored 99 out of 100 points in our observing and data stewardship and monitoring area, and we failed in one of these other areas. So we think that the whole, all the ships have to rise with the tide. So we would view each of these areas as extremely critical to have a successful climate service within NOAA. If you actually look at the core capabilities and you begin to think about, well, what are some of the sectors that are served by the basic services that are delivered by these core capabilities, this diagram just identifies a few examples, and we've got listed here energy, transportation, ag, health. NOAA doesn't own these areas by any stretch. There's other agencies whose mission, USDA, DOT, Department of Energy, Health Human Services, there's other agencies whose key mission is focused on these activities. But clearly we feel the activities that we're contributing with our core capability from these three components actually do deliver some basic level of services in these areas, and we would want to ensure that that would be continued as we move toward a concept of a climate service. But that doesn't necessarily mean that's where we'll end. The strategy that we're thinking about is that these basic services that are delivered for sectors such as those listed, others aren't listed, tourism, manufacturing, you can go down a long list, retail, construction. They're relying on past, current, future climate information. Again, the same thing I mentioned before, they have to be credible, transparent, reproducible. We think that these core capabilities in terms of delivering basic services can actually be the foundation for new services. And we would view assessments as a part of enhanced capabilities for new services. And the way we're thinking about assessments, as I mentioned earlier, we have the way we're thinking about this in terms of assessments divided into three different components. And you can think about these as nested components. One is the international and national climate assessments that have been done by IPCC, USGCRP. NOAA has played a key role, will continue to play a key role. These are, reports that have to follow the Information Quality Act. They're often defined by that act as highly influential. They're deliberative scientific assessments looking at the state of knowledge. They really look broadly across a number of issues. But there's a recognition that, and we've been told by many stakeholders, you have many useful reports, but when we have to make decisions, there's often not enough information to make specific decisions, especially at the regional and local level. So there's another set of climate assessments that we're identifying as problem-focused climate assessments. And again, if you're looking at the Information Quality Act, they may be highly influential or influential. The boundary, at least in our organization, is nominally, if it's over $500 million worth of decisions at stake, it's probably highly influential. Other than that, it's probably influential, recognizing it's always dangerous to try and add up dollars and cents in terms of potential impacts on decisions. But we're trying to get at the notion for the problem-focused climate assessments. These are really time-sensitive. They require delivery of actionable information for very specific issues. And I can give you an example of kinds of things we're thinking about. Some of you may know Devil's Lake in North Dakota has expanded the area of the lake size tremendously over the last 20 years. And the governor and the mayor and the congressman in that area have come to know and said, and USGS, and said, we have to make some decisions about moving businesses. We may have to make some decisions about building roads and bridges. These are huge investments for us. You're talking about in the hundreds and hundreds of millions of dollars. Can you help us out? What should we do? It's a very problem-focused issue. And so what you need to do then is to say, well, what can we say about the cause of those changes in lake levels over the past 20 years? Again, I mentioned earlier, these often aren't agency-led by one agency, because certainly NOAA has got the expertise in terms of trying to understand what's happening from a climatological perspective with respect to the atmosphere, evaporation, precipitation. Obviously, USGS has an important role in looking at the groundwater and the changes in land use around the lake. I mean, all these are issues. Could that be the cause of why this lake has expanded so much? We think that's just the tip of the iceberg. So these are another set of assessments. They have to be done on a more timely basis because decisions need to be made, and you can't say come back in several years and we'll have an answer for you. Simply because in that case, people are going to move on, make decisions without your information. And then the last set of criteria here is what we call stakeholder requirement assessments. And they're really, some people call them needs assessments, going out and talking to stakeholders and users who actually have to make decisions, trying to understand, what is it that they need, what is it that we might be able to deliver. They're often based on social science methods as opposed to physical, biological sciences, and they're part of this interactive service component. And you can imagine that last assessment has feedbacks back to the other two assessments. One of the key areas here then is to try and figure out a strategy for how far do you decide you go in terms of delivering information? Because as soon as you deliver information, there's likely to be another question. And often information leads to more sophisticated understanding of the problem, other questions. So one has to develop a strategy in terms of where the biggest bang for the buck is and continuing to pursue answers to the questions versus going on to new questions. So that has to be part of the overall strategy. So when we look for where might NOAA go with respect to new services if we were to have a climate service, we looked at for some criteria to help us. I've already mentioned there's some basic sectors we're already serving out there. And where we looked was, does NOAA clearly have a mission responsibility? Is there a stakeholder demand out there? Do we have any kind of a track record that would lead us to believe we'd have some success, some expertise? And do we have any resources that we might actually put on a problem? And we try to put those things together, kind of look across, and we came up with some notional ideas in terms of where we see some societal challenges that NOAA might be able to fill some gaps. And so if you look at those core capabilities, what we'd say is how can we look and prioritize within those core capabilities within a framework of some new societal challenges. And we've identified 5 areas, at least notional areas. First off, sustainability and marine ecosystems. And here's a case where NOAA is serving itself. We've got National Marine Service fisheries that manages fish off the coast. Questions that they're facing is how do we better manage, how do we provide better information for that resource management in terms of climate variability, climate change, climate impacts on those resources. So that's an area where we're trying to help better serve other components in NOAA. To some extent, same thing with coasts and climate resilience. We've got a National Ocean Service, lots of responsibilities along the coast. Try to better respond to their information needs, but also this is a recognized area of societal needs in terms of better understanding the effects of coastal inundation, not only sea level rise, but in combination with sea level rise, changes in storm tracks, storm intensity, wave height, storm surges, all that wrapped up together. Climate impacts on water resources. We've had a good investment over the past few years with respect to National Integrated Drought Information System. It's a system where we're working jointly with other agencies, both in the government and outside the government, to actually monitor drought conditions in the U.S., try to make a better effort at projecting changes in drought conditions, but working with stakeholders to try and understand what aspects of those projections and predictions that they would like to see. Another area, extremes in the changing climate. We spent a lot of time trying to focus on how extreme events might change as the climate warms. There was a CCSP, Climate Change Science Plan, report that NOAA led, focusing on looking across the area of North America, the Caribbean, and the islands, and looking at what do we know about changes in extreme events, what can we say about the future. This is an area, because we have a weather service, we think there's a lot of leverage opportunities in terms of trying to better understand how extremes in climate may affect, global warming may affect, or global climate change may affect changes in climate. And then lastly, informing climate mitigation options. And here's a case where, again, is an area that we think we have some important information, measuring atmospheric trace gases, both greenhouse gases as well as aerosols. And here is where there's important partnerships with other agencies, NASA, DOE, EPA, to ensure that we look at our responsibility more from what the effects are in terms of atmospheric composition changes, trying to better understand the fluxes. Certainly EPA is focused on the emissions. NASA is going to be flying a space mission to measure carbon. Clearly there's a partnership here, and we want to take advantage of that, but we think a NOAA Climate Service would have some things to offer. What are some of the ancillary benefits of addressing these particular challenges? Well, I think they will help expose the infrastructure issues and perhaps identify the gaps in the core capabilities. They'll lead to new services, be able to test the system end to end. We believe that they'll enable us to work with some new partners that we might not have otherwise worked with. And we think that if we focus in these areas, these initial areas, they're likely to have important ancillary effects in other sectors. And this is just a table trying to point out, if you looked at those example sectors I talked about, energy, transportation, agriculture, and just take the thing on the bottom there, the fourth one in the row, extremes and changing climate, clearly that's of interest for all the other sectors. So by focusing on that societal challenge, you'll bring along many of the other sectors by providing new and important information. We've got these things subjectively colored or just a little bit differently, or sized a little differently in terms of the circles, some smaller, some bigger, just in terms of where we think we might get the bigger bang for the buck. So the point here is simply that there's a synergy between the societal challenges areas, building up some of the core capabilities, and our ability to serve other sectors as well. Just a little more about these societal challenges areas, extremes in a changing climate. Clearly, there's regional information that needs to be anticipated for, you need to prepare for and adapt to extremes in a changing climate. And there are a set of user groups out there, from emergency managers, state and local officials, all the way to the insurance industry. I mentioned informing climate mitigation strategies, a number of user groups, policymakers, obviously the energy industry, and at some point in time, if there is a specific policy, clearly the states and local communities are going to be very interested in their carbon footprint. Climate impacts on water quantity, anticipate, prepare for, and adapt to drought and flooding. Here again, a different set of users, from water resource managers, civil engineers, farmers, other agencies, emergency management officials. This really comes to bear both in times of drought and in times of flooding, as I gave you that example with Devil's Lake. In that case, that flood wasn't something that occurred in a specific, one-day event. Here we're talking about an episode over a couple decades. Coasts and climate resilience, again, the local sea level rise, inundation issue, A number of user groups have already identified that as a key issue. And I mentioned the marine ecosystems, particularly our own agency, having some significant interest in that area. The core capabilities that I identified, I wanted to spend a little bit of time just talking about, well, what are we really talking about here? It says integrated observations, and I think there's a recognition today more than ever is we can't afford to go out and make new observations without close coordination of not only what our partner agencies are doing, but in some cases states and regions getting together and putting together observing networks. And so the coordination piece is really important there. Our goal here is to do measurements that not only make the measurements, but we want to preserve the historical record, preserve that data through data stewardship activities. And the idea here is we want to do this so that we can actually continuously monitor changes in climate for those periodic assessments that we talked about earlier. Research and modeling, critical. In fact, it's very hard to put up an observing system today without actually looking at the needs from the standpoint of evaluating how good we can do our models. But sometimes the models actually help guide us in terms of where we want to put observations. They provide a credible and authoritative science, and that's really critical to meet these needs. And so we feel this is a critical part of a climate service. It's got to be based on strong science, strong research, strong modeling component. In interactive services, I already mentioned that. This is a sustained interactive dialogue with the feedback that we think will be important to help build the other components. So if you look at those and consider them part of your portfolio, how would you go about putting investments if you had incremental new resources? And one of our strategies, I think one of the things that we want to do is we don't want to be driven entirely by the pressing needs of actionable information. Clearly that'll be important to be relevant. It's for near-term priorities. But we also recognize we're going to have some longer-term investments and payoffs. So we will want to have a balanced portfolio on the climate service. We want to ask ourselves how will we manage the portfolio. Our goal is to develop this portfolio so it's scalable, so we're not subject to the vagaries of the budget. If we go up 1 year and down 1 year, or go level and have an incremental large increase, the key here is scalability. So I think that's one of the things we're going to look for. We, again, will use those core capabilities as the key to getting to those societal challenges and those basic services. In our portfolio management, one of the things we'll want to do is have some assessment of why we think we'll be successful. In other words, if you're going to take a chance, you want to have some justification for why you think you're going to make this work. And again, knowing who your users are and who your partners are, and then in the end, defining your success. So before I'm getting close to the end here, I just wanted to talk about where we are now, and this gives you a little bit of an idea of the labs and centers that we're thinking about for a climate service. You know, where are there resources in the agency now? And we've got a notional chart here for OBS and monitoring, research and modeling, interactive services. We just X'd out the greater number X's, the greater the investment is. And then we've tried to look at it, well, what proportion of those dollars are spent inside NOAA? What part goes to other federal partners, other agencies? What part goes to grants? And this is largely the academic community, but not exclusively. What part goes to contracts? And those are often for-profit companies that help us manage observing systems and provide services. And we've got another column here called intergovernmental personnel assignments. Again, that's approximately 0% you'll see on the key, but we just didn't want to forget that we actually have that tool as well. So that's where we are now, and you can see that interactive services development delivery, I guess the take-home message here, you see mostly single X's. And clearly, it doesn't mean it's less important. It takes more resources often to put in observing systems, to do high-performance computing, modeling capabilities, a serious investment in dollars. But clearly, there is a demand in the interactive services and development delivery to develop what we call boundary people. People who can have one foot in the first two rows and another foot in the third row, going out, talking to stakeholders and users, understanding their needs and recognizing what it is that the other capabilities have to deliver. And those are new people that don't really exist in a plentiful measure. I don't think our universities actually have courses training people to go in both areas. And so these are usually people who do this out of a labor of love, and we think we're going to need to encourage some development in our academic communities for these kind of individuals and value what they could bring to the table. So we think of partnerships, again, same kind of a diagram. Here's who we look at in terms of our partners now, either internal NOAA, that means other line offices in NOAA, other federal agencies with these components, international agreements and cooperation, and it was pointed out we should have had an X on interactive services because there is some activity going on there. Academic partners, private sectors, NGOs. So important to see that. And then it's important to see where you think you might go. And we did this for these example societal challenges in terms of where we think we might want to invest to address some of these issues. And so again, these are notional diagrams, but it gives you some idea of how we're trying to think about our ability to move forward and who we would be relying on in these various areas. And then lastly, just to close, it's going to be important for us to come up with good criteria to evaluate how effective we are. There's a lot of good information, a lot of criteria from National Research Council reports on how to do this. We have a NOAA Science Advisory Board. There's Eric Barron put together a report that helps us in this area. I think there's clearly a strategy that says, we need a continuation of independent external reviews, internal reviews, using both objective and subjective measures to see if indeed we're successful in the areas we set out to provide new services, to see if we're continuing to provide basic services as best as we possibly can. And the recognition is that some of these measures can be objective, but some of them are likely to be subjective. The last slide here is next steps in terms of where we're headed. We've got to develop business practices that strengthens our science by also growing the demand for new services, or not growing demand, meeting the demand. Engaging internal and external audiences, clearly that's important. We're hopefully going to have a completed set of regional climate service directors later this fall. These are regional climate service directors in 6 weather service regions that they'll be sitting at to help coordinate a lot of the services that already exist in the region and help identify those stakeholder needs and translate them back to those other core capabilities. We've got a climate portal that some of you may have seen. That's going to evolve, and our intention is to try and connect that to other agencies to try and ensure it's not just NOAA's data, but to see if we can't make this a little more broadly effective, looking across other agencies first. The grand vision, you can imagine a national climate portal bringing in agencies, state agencies, and municipalities. We're hopefully going to submit a reprogramming package to Congress as soon as we possibly can for the fall period. We're awaiting a National Academy Public Administration report that's going to go to Congress September 14th, and subsequent to that report, that was a report called for by Congress to look at options for a NOAA climate service. Subsequent to that report, we would hope to go forward with a reprogramming request. If you want more information, here's a couple of websites. that has information relative to our thoughts on the climate service. So I'll just leave this up, and you can write them down if you're interested. So I guess we'll have a panel discussion. We can answer questions later. Thanks.
Thanks. What we'll do now is move to the panel. I think the easiest way to do it might be just to go down the row. I've asked each of the speakers to talk for 5 or 10 minutes, and then we'll open it up for questions. So, Jack, why don't we start with you?
All right, thanks. It's a pleasure to be able to be here. I just wanted to give kind of the NASA view from space for some of the things that we're doing, and to try to put it in a bit of a broader perspective, talking some about where we are now, but where we're going and how that relates to the broader external picture. From the point of view of where we are with global Earth observation from space, it's a great time. We've got 13 operating missions, big, small. Oldest one is the major missions is just about a teenager. These are things we do with ourselves, things we do with partners. We've got 7 missions in formulation and development. So, you know, we've got the ability to view our planet in ways that, as a species, we've never had before. And we're discovering new things, but we're also being able to characterize things, documenting evolution. In many of the things that we do, we have equivalent quality data anywhere in the world, which is something that we really have not had before. So for things like revisiting the poles, satellites may fly over each pole 16 times a day. It's very good coverage. We accompany that with vigorous programs in research, applied science, and technology, so that there's a large number of funded investigators around the nation who are able to use the results of the observations for quantitative science, and also integrate them into sort of multifaceted research efforts that involve planes, ships, surface-based networks, and computer modeling. We can't do everything from satellites and the networks and airborne and now a little bit ships are helpful in terms of getting data that satellites can't get, getting complementary data, supporting it through calibration and validation. And just as an example, as we speak, we've got a major ship-based campaign on the Coast Guard cutter Healy that's been in the Beaufort and Chukchi Sea and returning to Seward, Alaska tomorrow, really trying to look at sort of changes in especially ocean biology in the Arctic Ocean, because there's so much more opportunities, there's less ice there. And we're about to begin a major multi-aircraft and coordinated multi-agency campaign trying to look at hurricane genesis out in the Caribbean and Atlantic on August 15th. It's the Genesis and Rapid Intensification Program with our ER-2, B-57, and Global Hawk is UAV, which will be working in conjunction with NOAA and NSF observations. Doing all this work, the interagency partnerships are a significant part of what we do. We are far and away the largest contributor to the U.S. Global Change Research Program in terms of the identified dollars, and we support administration initiatives in oceans, Earth observations, and natural and unnatural disasters that we've been working on. Unfortunately, quite a bit of that the past few months. So that from a bigger picture point of view, you know, we're doing a lot. We're sort of very well positioned, I think, in terms of where we're going as a nation, both in terms of what the administration is telling us and increasingly what Congress seems to be willing to do for us. The space policy that was just released made very clear statements about the importance of our role in Earth observations, both in terms of the research that we do, the role that we play with other agencies, primarily NOAA and also Department of Defense relative to operational services, especially NPOS and the transition to Joint Polar Satellite System, and specifically now with the U.S. Geological Survey and land remote sensing. So there's very clear direction for the kinds of things that we're doing as part of the space policy. There's also a segment of the space policy that relates to international cooperation, and that's a particularly important thing for us. As part of what we do, we coordinate extensively internationally through the Committee on Earth Observation Satellites, actually lots of organizations we can coordinate internationally with. And that coordination can vary a number of ways. It can be joint projects where sort of multiple nations' instruments may fly on one nation's spacecraft and vice versa. We've especially done a lot of other people flying instruments on our spacecraft, but we've done a little bit of our instruments going on others. Calibration and validation is very important. there's enough variability in the Earth, in the biogeochemical and geophysical regimes, that being able to convince people that we're getting it right is something that you have to have access to people's territories and their assistance in doing that, so that's very important. And finally, data sharing is an utterly crucial thing, and that's something that the international group on Earth observations, the GEO and GEOS efforts are really critical in trying to enhance. The data shared are much more valuable than data hoarded. And I think the U.S., we've traditionally been leaders in making that data available, and I think we're seeing others coming around to that, but especially as we get to a wider suite of international partners, that becomes an increasing challenge for us, to people to have that degree of comfort that, if they share their data, warts and all, we'll all be better off. We will be, but not everyone gets that right away. Then the administration's budget, the past couple of years have been very beneficial for us. There's an increase in FY10, but especially the FY11 budget that the administration proposed for NASA Earth Science increased us by about $2.4 billion in run-out, which is more than a third of the NASA budget increase that the administration had proposed. And so far, I think what's happening on the Hill seems to suggest that that's what may actually get incorporated into law. There are a number of key elements on that. Acceleration of decadal survey missions, that just budgets were going to limit the rate at which we could roll them out. Still not all in the decade, but we're looking at a appreciably more rapid rollout than we were before. A reflight of the orbiting carbon observatory mission that we had a launch failure in the fall of 2009, so we can plan for a 2013 launch for that. A new line of what I'll call climate missions. Those are some things that especially there is recognition that there are some data sets that we really need to ideally be continued or minimize gaps, and there are things that we couldn't realistically expect operational agencies or even their international partners to do because of the specialization associated with that. So we're looking at starting some of those, SAGE-3 on space station, a GRACE follow-on, and a PACE mission, especially for ocean carbon. We've got a venture class, which was a set of missions that the Academy did call for in the decadal survey, but that would be annual solicitations for instruments to go on a variety of spacecraft, especially sort of missions of opportunity involving partners. A small satellite call that we hope to do, and we already started with an airborne call for sustained airborne observations and selected 5 airborne missions for about a total of $150 million for up to 5 years. There's a non-flight component to that, and I just want to mention a couple of them. One is a carbon monitoring system. It's kind of a bad name for it, but we had gotten some congressional direction this year to spend some money on what was called a carbon monitoring system, delivering pilot products, and I think the sense is that that's a good idea, and we're going to sustain that as part of the budget augmentation. Because really, if you look what we're doing, especially through the decadal survey, as well as the orbiting carbon observatory reflight, the PACE mission, we're talking several $1 billion of investments that are going to provide a wealth of new observation about carbon in the Earth system, carbon in the atmosphere, biomass on the ground, vegetation, canopy heights, carbon, terrestrial productivity, as well as land cover information. So how one can really ingest and synthesize all those data to produce products is a significant element for us. We've got a severe activity in which we started this in Central America. We're extending it to East Africa and now to the Himalayan regions. It's become a significant partnership with the Agency for International Development to help get the information out there and utilized, especially in developing areas where they've got limited information available to them about their environment. And in fact, the NASA administrator is this week going to be going to the new Sophia node in Kenya to be visiting there. We have the GLOBE program, Global Learning and Observations to Benefit the Environment. It's been NASA and NSF and NOAA's partnering as part of that this year. That involves students all over the world taking data, sharing data with the joint infrastructure that we have primarily in the U.S. And it's just an absolutely marvelous way to really get people working together. It's also, at NASA, if one looks at the number of our international partnerships, there's 2 things where we have the most. One is GLOBE, the other is AeroNet surface-based sun photometers. And we've got partnerships all over the world, especially beyond our traditional partners in terms of the countries that one would normally expect to work with. And finally, one thing is that we are very much interested in utilizing data with a range of partners. And one of the things that we're starting with this year is a partnership with actually we started last year with the Environmental Monitoring Division within NASA as part of our Office of Infrastructure, really trying to find a way to connect our science to the people who manage our unique facilities and infrastructure and centers, so that they can begin to think about, in a changing and varying climate, what steps should they take to try to look to the long term, and how can we apply our science and get our scientists to work together so that they can really build on what we're learning and sort of help ourselves out first. And I think in doing that, that becomes a pathfinder for the kinds of things that we all collectively are going to do in terms of getting our environmental information and making it more useful for management, policy, and decision making.
Great, thank you.
So I just wanted to add on to what Jack was saying, but step back even a little bit and talk about Earth observations in general and what the administration's thoughts and ideas are for this. So it goes without saying that Earth observations, well, it's a priority for the administration, and it goes without saying why this is. We live in an era of unprecedented stress on the planet. So if we're talking about whether it's population growth, climate change, resource demand, continuing development of coastal built-up areas, all of this is going to basically mean unparalleled challenges for our health, economic, national security, resource management. And so therefore, a robust infrastructure of Earth observations is going to be very necessary for informing decisions and for policymaking. Right now, the myriad of Earth observations from space vary pretty widely in purpose and are spread amongst numerous programs under the purview of several federal agencies and institutions. And to a large degree, these observations have only been loosely coupled, coordinated, and integrated. So one of the things the administration is focusing on currently is the development of a comprehensive strategy for Earth observations, including both from space and in situ, because the administration also recognizes that a coordinated approach is needed to sustain and build on the current set of Earth observations, including both NASA, NOAA satellites, USGS, and others. One of the first things on the administration's plate, though, was the NPOS program, and so basically the restructure of the NPOS program and taking a look at what was bounded in NPOS was a first step, because so many measurements, be they continuity of either NASA, current NASA or NOAA measurements, were looked at, were focused on NPOS to have the continuity of these. And at one time or another, either the Landsat measurements were supposed to be continued through NPOS, ocean altimetry, aerosol polarimetry, amongst numerous other things. Some of those have their own missions now. Some of those will be continued on NPOS. So a number of other steps were also necessary. Jack talked about the augmentation in FY11. That was a very important step to bring NASA's Earth Sciences budget up to the point where we could do many of the things that were on the plate talked about in the decadal survey. So accelerating a lot of the Tier 1 and Tier 2 missions. Also, revitalizing USGCRP, the U.S. Global Change Research Program, has been one of the priorities. In fact, USGCRP has even reviewed NASA's FY11 augmentation plan, and these reviews are going to be taken into account as NASA moves forward with implementing the plan. And we intend to utilize USGCRP in a similar manner in the future as a mechanism for ensuring broad federal coordination on climate observations. USGEO is another area that we're focusing on pretty heavily, the U.S. Group on Earth Observations. And in November in Washington last year, our Associate Director, Sherry Abbott, chaired the 6th plenary session of GEO, the international body of which U.S. is a part. And so we've been utilizing USGEO. They have a strategic assessment report that was worked on last year, which the GAO actually mentioned that the administration should finish this up and release it, and we're working on that. And it all basically leads up to something that will be a priority for administration this coming year, which is to work on a national strategy for Earth observations, take into account a number of the works that have been done before through things like USGO, USGCRP, previous Executive Office of the President, NSTC works that have been done, and look at the coordination of multi-agency initiatives and budget submissions from individual federal agencies. So I'll just leave it there and turn it over to Anna.
Okay. Thanks. I'm glad that I could join you today because it means things continue to be relatively quiet in the Gulf, which is a great, great thing for all of us. And we are very much hoping we'll be on the final solution for this wild well here pretty soon. It's always great to be here at CSIS, and in fact, I was here in December 2008 on a very similar panel, and my message then was that Earth observations, especially for greenhouse gases and climate services, were very important to our nation, but that Congress was not very well educated on those points. And pretty much not much has changed on that front, I'm sorry to say. But some things have changed, and I think it's important to talk about those and where we might be going forward from there. Obviously, we've heard a lot of the good work that's happening in NOAA and NASA and in the broader federal agencies under the guidance of OSTP. So I think those are important developments that will influence Congress as we're moving forward. But just sort of to recap things that have happened in the House a whole year ago now, June of 2009 was important for climate services in two respects. The first was that an amendment to prevent NOAA spending any money on climate services was actually defeated. That was actually our first big climate vote in the House of Representatives in this Congress. And then just a few weeks after that, the House was able to pass the Waxman-Markey bill, which was our comprehensive energy and climate legislative package. That did include support for a national climate service and coordinating these issues. I personally think we could have had a little stronger package in that bill, but I'm sure all of you are familiar with some of the jurisdictional struggles that go on. And in the end, we were able to preserve supporting that idea. And hopefully it will be something that we can build on going forward. Unfortunately, as is the case for many issues facing the nation, the Senate is a little more challenging place these days. And on the issue of climate services in particular, as a part of climate legislation, they've actually gone a little backwards. So the Kerry Boxer bill that came out at the end of 2009 did include support for climate services. The subsequent sort of narrowing of that bill that has led to Kerry Lieberman has really dropped that as a component. And I think you're probably, all pretty aware of what's happening in the Senate now, that the package they're trying to put together to bring to the Senate later this month that will encompass both energy and sort of oil spill response, as well as some climate things, will be extremely limited on the climate side. And so I don't really anticipate as a part of that legislation or language that really leads to climate services or additional resources for observations. We remain hopeful that the Senate will be able to pass a sort of energy package that will include climate policy in it. And then, of course, we'll be in a sort of conference committee situation, and we'll see what the conferees can do to take part of the components from the House bill to include that in whatever final bill might go to the president. So it's still a little cloudy. Now, of course, the issue of Earth observations and of climate service doesn't need to be part of a climate package or maybe a broader energy and climate package. I mean, it has its merits to stand on its own. Obviously, the challenge facing us is just budgetary constraints, and so from my perspective, having it as a part of a comprehensive climate piece that is generating some revenues that at least in part can help support those resources would be a good way to go. I think, even if we make a start on climate policy by the end of this year, the generation of revenues or resources from that will be extremely limited. So in the near term, it's probably not going to be a source of revenues that can go towards these types of observations and service support. And Tom said something interesting in his talk. He said sometimes science leads, sometimes the users lead, which I would agree with, and I would add Congress always follows. And so to that point, I mean, is where the real necessity for Congress to hear from stakeholders of all sorts that these type of services are needed, and federal support for developing them is needed. So I mean, people need to hear from their North Dakota mayors that they need information in order to design roads and build new facilities and even deal with the location of their towns. Congress needs to hear from business leaders that having some idea of climatic impacts that influence their business decisions are necessary. I mean, obviously, even without a climate bill, we're seeing a real change in our electric production and delivery systems, and many of those will be driven, or at least better decisions could be made about the future of electric production with this type of climate information. So, renewable energy producers are going to need better both near-term forecasting of wind and sun resources, but also longer-term understanding of how those resources may change as the climate changes. For more traditional power suppliers, especially those who are reliant on cooling waters from rivers, the amount of water in a river as well as the temperature in that river is going to be critical to their operations. So there's a lot of places where this information is incredibly helpful for businesses making decisions, and Congress really needs to hear from those stakeholders to move forward in supporting these type of efforts. I think, the case is beginning to be built, both from, the actions that the executive agencies are taking, from some of the work that NOAA is engaged with the National Academy of Public Administration, The National Research Council have had a couple of important reports, two to just call out. One was in March of this year about verifying greenhouse gases, which I think was a very helpful report because I think the panel sort of surprised themselves that it would actually be in the relatively near term. I shouldn't use the word easy, but we can get to a capability rather quickly to have very strong or robust monitoring capabilities, especially for carbon dioxide, both from a sort of traditional accounting method, but also supplemented by direct monitoring. There are some challenges with some of the other greenhouse gases that we'll want to monitor, but those, hopefully this report will draw some attention to those. And then, the NRC has been engaged in a whole big series of called America's Climate Choices. 3 of those reports are out now, and actually the 4th one is coming out tomorrow. And it will have some interesting and supportive things to say about a national climate service. So I think all of those will be helpful in underscoring the importance of both observations and supporting the buildup of a climate services that may span some agencies, but dedicating resources to that. So I think I'll probably leave it there.
Great, thank you. So what have we heard, roughly? We've heard we've got a new national task. You all knew that, right? I think what we heard is we need to transition in some ways from what's been largely a research-focused activity to one that's now more of a service activity. And this might involve getting information and data to a new set of customers, may involve some repackaging of that data, but it's going to be something where we'll see increased demand, right? And then one of the issues that's come up, I think, in all the speakers is, do we have the right structure? Do we have the right set of investments? Are they adequate? Do we need to increase them? Answer on increase is always yes. So with that, why don't I see if there's questions from the audience? I might start with one, which is just going down all 4 of you. When you think about this field and when you think about what we've been talking about, where do you see the growth areas in this service activity? Who are going to be your best customers 3 years from now? I don't know if you want to try Anna. Maybe you started with the mirrors and all.
Well, I grew up out west, so water issues are always high in my mind. I think water managers of all types are going to be important users of this information. And then I guess working for a congressman from Massachusetts hat and having grown up on the Texas Gulf Coast, I think also the coastal issues, both on sea level rise and increased storms, are going to make coastal communities very interested in this type of information.
I think it'd almost be easier to list who would not be sort of a customer for this kind of information. Basically, so in the year, I've been at OSTP, been focusing obviously a lot on Earth observations, the infrastructure side. Others have been focusing more on the climate services assessment and specifically adaptation. So we have folks that are very focused on each of those areas. So I'll just say, I'll be brief and say the folks that are doing the adaptation part could probably come in here and give you a half an hour long list, and they're traveling around the country talking to stakeholders and groups. It's really amazing what they're doing. So rather than pick out 1 or 2, I'll just stop there.
Yeah, I was probably going to echo what Johannes would say, is, who won't be using it? It's hard to, I think, even sort of predict exactly, who's going to do this. I mean, I might say in general, I think that we've probably underestimated the demand for things, especially even on the research side. You start doing something, you make it work, then you kind of make it work routinely, people start figuring out how to use it, and suddenly it's like, your research organization, it's behaving quasi-operationally because people want your products all the time on a regular basis. And that happens all the time with an increasing suite of users, and I think our goal is to help expand that pool of partnerships, especially within the federal government, but ultimately I think to try to figure out how to engage a broader range of stakeholders. The one point I might make is that I think it's very easy for us to fall into a domestic focus on this, but to recognize really looking at international uses is a critical kind of thing, because in the US to some extent we have a lot of data. And in some places in Western Europe. But you go to developing countries, especially countries with political instability, they're so limited in their ability to gather and sustain and nurture environmental information. And since so many of the global issues that I think we're going to be tackling, they're going to be coming from outside the US, so it's going to be a mix of people in the other countries as well as people in the US who are concerned about development and those sorts of things, and really having equivalent quality data anywhere in the world, I think is going to just dramatically increase the nature of users, especially beyond those who we might naturally think of.
If I could just follow up on that for a minute. When you look at the country, you mentioned cooperating with a range of countries at one point. And how are those changing? It's going beyond our traditional space partners. Who are the new folks?
Well, it's a range of things. One of the things is that at NASA, in particular, say we're a space agency, but we're a science agency, and in Earth science, in some sense, we're an environmental agency. We don't make policy. So in the space world, it's the traditional partners of Western Europe and Japan, but now we're working with Argentina on the Aquarius satellite. One of the things that we'll need to figure out is to what extent we're going to be able to engage with India and China. Some of those things, it's not just up to us, but my boss will be going off to India in a couple of weeks, and there's others. Korea just launched a satellite. The first image came off of that. So on the space side, it's really the new spacefaring countries that we'll be working with, and then in things like calibration, validation, and networks, we're all over the world, and in trying to work with agencies to get information that will help us interpret our satellite data. We're doing some work with other agencies, especially the Navy, trying to look towards some things in Southeast Asia where we've got plenty of satellite data, but there lots of clouds, lots of aerosols, lots of pollution. How can we combine satellite and in situ data? So those sorts of things. And then from a science point of view, especially, how do we get people utilizing that data? That's where severe and things like that can be very important, and working through or a variety of international organizations. And there's really no limit. I mean, the limit in many cases is what I think infrastructure and human capital exists within those countries to work with us. So we have to help build the capacity and work with the development organizations to be able to get the data utilized.
The only thing I would just mention, I think Jack really nicely hit on how partners view the data. And I think the key issue is going to be the multitude of sophistication among the users, both internationally and nationally, and trying to find out how we're going to service those broad spectrum needs. I don't think we have the right formula yet. It clearly has to be something worked on, and that's why I mentioned these boundary kinds of people that are going to be increasingly important to better understand that. And I will make one prediction. My prediction will be that it will be through these extreme events that the recognition for the need for climate information is going to hit home. If you actually look at projections in the future, and you take a look at, unfortunately, what we do too often in the climate science world is we integrate and average, and you see these nice smooth lines, and you have this anticipation that climate's going to just change gradually. When you actually decompose and look at any one model projection amongst the hundreds that are out there, you actually look at how these things occur, and you may find 10 or 15, 20 years ago, things kind of go pretty much as you might expect as they had in the past, and then you get 1 or 2 years where you get natural variability on top of an ongoing trend, and you get some major changes. And so it's those groups who probably have not anticipated that kind of event are going to have a great demand for information. And I think our task is to educate as many as we can so that we don't end up, Johnny come lately. We want to be aware of these events so they cause minimal damage.
Did we have a, go ahead.
Question, did anybody want to?
Well, I've been mainly thinking about oil spill and not climate for the last few months, so maybe I should take a crack at that. I mean, I think one thing that has happened is we have seen some creative response and movements going forward, and one is, I think Jack sort of alluded to it, the partnership between the USGS and NASA to do some plane-based remote sensing with spectroscopy and they've basically developed a new technique to better map oil and its true thickness on the water and impacting the coast, and I think that's going to be really important information going forward. Obviously, there's been a huge scientific effort in response to this, both for NOAA through the Natural Resources Damage Assessment that they're legally obligated to do, but also through NSS rapid grants to researchers. So, we're going to have a lot of information come back. I know NOAA has put down put out a lot more sensors in the Gulf as this has transpired, and we hope that those will be able to stay in place for longer-term observations. We had bills move through the Natural Resources Committee and the Science Committee in the past few weeks. And now we're trying to put that would include further support for observations and research. And we're trying to put together a House package now to bring that to the floor. So those discussions are ongoing. And so, I mean, certainly for the last 3 months, I mean, people have been highly focused on the Gulf spill and the impact on the ocean. And what's been interesting, just following the polling, is that has also been informative, I think, to people's thoughts on climate change and global warming and support for renewable energy. This spill is a pretty visible carbon pollution, whereas the past few years we've been trying to talk about relatively invisible carbon dioxide pollution. And so I think, that has helped. Has it also helped that we've had record heat? And, this is this half of the year has been the hottest first half of the year on record. That also is probably helping refocus people's minds on it. And, as Tom mentioned, we've had some extreme flooding events as well. So I think the challenge is really to kind of tie these things together in people's minds, and to some extent that's happening, I think, in the broader nation. I mean, understandably, the Gulf Coast is very much focused on oil and its direct impacts on them and their livelihoods.
One thing that this is maybe something Climate Services can help do, and this is no way tries to diminish the magnitude of the oil spill, but when you turn on the news at night, you actually see outside the last couple of days the oil before your very eyes, gushing out of that leak in the Gulf. if you actually try to equate how many oil spills like that you would need to just have an equivalent of 1 year's worth of carbon dioxide that we emit to the atmosphere, you need 3,000 of those kinds of oil spills. And the problem that we face is that the carbon in the atmosphere is invisible, it's not noticeable, and in fact, some of it is absolutely critical for life on Earth. And so I think we don't do as good a job as we could by trying to step back and communicate and give the right perspective to people to think about some of these issues. And I think that's a challenge for climate services in terms of enormous amount of information, very potentially sophisticated, complex information. But if it's not brought down to the level in which we all can easily understand and comprehend, it just makes it more difficult for us to get across the notion of the importance of trying to prepare for this. Thanks.
Marisa Lino from Northrop Grumman. This is for Dr. K, although anyone else, feel free to comment. You were talking about sharing climate knowledge with the developing world, and I think it makes enormous sense for us not to have developing world duplicate what is already being done in the developed world. You've had, from what I know of Servier, great success on extreme weather in working in the developing world. I wonder if you feel there might be resistance from the developing world or suspicion with respect because of the politics of climate science as opposed to extreme weather, which everybody has to deal with, projecting long term on climate science, whether there'd be resistance or suspicion with respect to the data coming from the United States government as opposed to internationally.
I'm certainly not aware of cases where, say where I've heard of people saying they don't trust, they don't trust the data that we produce. At NASA, at least, I think, and I think on the whole that's true for the other agencies, but the satellite arms of other agencies, we don't regulate, we don't make policy, and I think that we have a perception of objectivity. So, could that happen? Absolutely. From my own point of view, I think that it's important that other nations join the club, and that it's not just us who are doing that. And while some might see that as duplication, one can see that as resiliency. I mean, we're now, I think, really trying to have a good conversation with India about their OceanSat because there's a real opportunity to utilize their data. So I think growing our national capability, all of our national capabilities, is helpful. The weather world has been doing this for quite a long time with data sharing and staged orbits and things like that. That's worked very well. The other thing is that in general, I think, especially when one looks at things like the IPCC, having data coming from the country, the variety of countries, and having the science manpower to do that, I think that just helps everybody because then that way, because those are supposed to be jointly written, jointly reviewed data assessments, and if they can draw on data of especially known quality and data that's intercompared, I think that's only to the good. I think it's important that as others start to do this, that we try to be helpful, try to help them succeed, but also try to, ideally make sure that intercomparisons are possible, things are traceable to recognized standards. But we do that in a supportive way as opposed to we're the only ones who know how to do this kind of approach, which is not unnatural for people who have been the only one doing that. So I'm happy to see them do it.
There's been a great deal of focus under the new administration and the open government and putting open data sets, particularly on data.gov. And when I hear about climate data, I went to climate.gov, and then try to navigate to where the data is located. And I didn't see any easy way to download a bulk data set. So in terms of, and I may just be missing it because I'm right here in the moment, what are the tools that you anticipate putting out there in terms of enabling that kind of download and partnering with the ecosystem that's grown up around the use of government data to show meaningful patterns, particularly with regards to visualizations or mashups and maps that can help the public understand what's happening as well as the scientific community?
Yeah, no, that's a great question, and the climate.gov site that NOAA has is right now really a prototype activity, kind of a first level to point you in the right direction. But you should be able to get to, for example, with climate data, the NOAA National Climatic Data Center, do bulk downloads. In fact, if it's a huge request, they'll actually work with you to schedule what you want. But I think your other question is, do you have it geospatially located? Can you use existing tools? And to some extent you can. We're certainly not where we want to be. I would think this is a clear area where there's a recognition that there's enormous potential. And I think John was asking an issue about opportunities, and I think the oil spill also pointed this out. One of the key areas is there's lots of data out there. Getting it organized in a manner in which is useful for a variety of slices and the way you might want to dice the data and have this traceability and reproducibility is really a key issue for us, and probably need to think about how we can best do that, not necessarily, as I mentioned, as an environment that's only federal partners, but actually try to reach out and work out method to bring in other partners. And that really means you have to develop some standards and protocols that all can play by and abide by. So when you get to the data, you get to the information, as Jack said, you can then have some sense that this data is reliable, whether it comes from a developed country or whether it comes from a municipality or state agency. So clearly is an important challenge, and I think it's something that the federal community and US GCRP is going to put as a high priority.
A little bit. I think that one of the things certainly that we've done over the years through our Earth Observing System data and information system is to invest a lot in terms of making data available with a very open data policy and a lot of documentation out there, algorithm theoretical basis documents and things, so that everybody can see exactly what people are doing. So I think for most of the satellites, or pretty much all the satellites that we do, the data are made available as rapidly as possible. I think just the sheer volume of the data and the complexity of it makes it, I gather, challenging for less sophisticated users. And so therefore one of the challenges and responsibilities for us is to develop tools that will facilitate, say, the less knowledgeable user. And there are a bunch of really cool tools that people can use to help people, because in many cases people don't want everything. They may want certain things associated with a particular place or a particular season or a particular phenomenon, and the subsetting becomes a real issue. We've got research programs that help generate some of those tools. I think that something that, as I understand it, is one of the things that the US GEO is out to do, is to sort of facilitate multimodal study, because while we may do well with the satellite data, and I think NOAA does very well with the satellite data, if somebody says, okay, but I want to now get the in situ data from a state regulatory network, or I want to get the data from something that the municipality may do. They're not all set up the same way. So there's a real challenge in providing a common approach for people to get, to drink from the fire hose of data, where there's massive investment to support that, and the people who want the dribs and drabs of data coming from sort of a much larger set of players. But from the point of view of science and applications, you need to be able to integrate. So I don't know whether you want to say anything about the role of GEO in doing that, but I think that is a challenge.
No, that's a pretty good overview.
We have, I think, time for one more question, and I'm going to throw, I hate to turn people down. Can we take two? You guys have enough time? Yeah. All right, well, we'll do it, and then I had a question, but maybe I'll skip it.
Yeah, I guess if I understand the question right, it's more of a, can we get an international climate service as well as a national climate service to try to understand what the needs, I mean, it sounds like the DoD certainly will have needs to understand impacts around the world. Actually, yeah, in fact, I've been talking with USAID pretty regularly about, and the geographer, the one, and the few GIS people who are there, for how we can help better coordinate across agencies. I think actually your own answer to, well, one of your own answers actually touches on it pretty well, which is USGCRP right now is a pretty good odds-on bet for one of the routes or avenues that you could actually go about getting the kind of information you need. With the revitalization of USGCRP, that's exactly what its role is to coordinate not only the information from national but international as well, coordinate across all the agencies, and therefore the internet data that has been shared across the international sphere. So I think, we'd be happy to have folks from your shop. We've talked to Admiral Titley. He's been in at least once, if not more, and that's the kind of engagement we're trying to encourage, if anything. So give me your card. Yeah.
I would just add to that. I mean, I know in the last few years, the National Intelligence Council has done a national intelligence assessment of climate change, and obviously that's a little longer term. It doesn't help the Navy on their sort of shorter term operational questions, but I think what came out of that was a pretty healthy partnership, both with federal agency scientists and some academic-based scientists, and I think they're supposed to be continuing that partnership to further refine some of the questions and areas that they acknowledged as sort of found as gaps in what they could do in doing that first NIA. So I think that's, was an important development and one that can continue maybe in the interim period, and then ultimately can interact with a more nationally based system to get our agencies that have an international focus and a need for international impacts the information that they need.
Yeah, we had the people who did the NIA here about 6 months ago, and maybe we'll get them again if they're doing more work. But we have time for one more in the middle, and then I'm going to have a concluding semi-question for people. Right behind you. Yeah.
Oh,
Sorry.
thank you. My name is Christopher Kraus. I'm from the National Environmental Education Foundation. I was just looking over the UNFCCC identified 44 essential climate variables, and then there's 26 of which can be monitored from space, and then currently we're monitoring 16. I guess, I have a couple questions. I mean, number one, that how crucial or how important are those other 10 variables that we're not monitoring? I mean, is it worth us spending the money actually putting satellites up there to monitor them? And then my other question is just, at the rate we're going in, I don't know, 5 or 10 years, how many of those 16 variables that we're monitoring now will be monitored then? I mean, it looks like we're losing satellite capacity just based on the graph I'm looking at here, and I think there's a link to a report which I might check out, but if you could just kind of give me maybe a little brief synopsis of where our monitoring abilities are going as it looks now. Thanks.
Yeah, I'm sure Jack will probably want to respond, but I can say from our perspective, looking at those ECVs, a couple of questions would come out. One is recognizing you don't have unlimited resources and you don't have unlimited expertise. First question would be, can you actually measure the ones that we're not measuring reliably? And would it be experimental to go out and do that? And if it is, then you've got to get an experimental program. And then you have to weigh, if you do get new resources, great, you can invest in whether or not we might be able to do that from space. But then weigh that against, we have to make sure that the long records we currently have in place, we continue to preserve those. And so the ECVs, I think, were a great concept that GCOS put forward, and a number of us participated in helping develop those, and they're adapted in the Climate Change Science Strategic Plan back in 2005. But what that doesn't tell us is, for those variables, what are the questions you're trying to address? And I think there's some homework that needs to be done to say, you know, if you're going to answer question A, you know, trace back what are the key components, the key gaps. And if you judge that question as most important, you may favor investment to answer that question compared to some other ones. So I think there's still a little bit of homework. I think it was a great, you know, incremental advancement that the climate community made by identifying what would be key for a general climate system understanding. But from the perspective of what are the specific questions, I think there's a little more work that we could do because we're not quite there yet. Jack?
Yeah, I think that it's certainly a really good thought process to go through. I mean, but at some point, then, you know, you do as much as you can, and you use lists like that to help you. There should be a real high bar associated with something if you say it's something that needs to be monitored from space. You know, and there's some yardsticks that one could probably use, like if it's something that can be realistically calculated and inferred from other things that you're monitoring, maybe you don't really need to monitor it, just calculate it, or you can assimilate it. But then, you know, you also have to understand when you know, what do you mean when you say monitoring? Because, you know, what is any one agency doing, or are there ways in which we can work together internationally through a combination of research and operational sensors to put it together? So that, you know, you may not have something that someone say is an ideal monitoring system, but you're never totally naked in a particular area, and you find a way to make do. So, because the community is pretty creative and will try very hard to help get through what might be rough periods. And finally, another thing is, you know, to really think about, say, just because you've started something, you know, does that mean that you have to do it forever and ever? As a community of researchers, we're not very good about saying, thank you, that's enough, we don't need that anymore. You'll seldom hear that from a bunch of scientists. So there's a tendency for these things to proliferate, and there's always value in doing more. And because there's always information, but I think, as Tom said, for specific questions that you're trying to answer, some things you really have to have. And you know, of course, the space is really valuable, but even the things that you monitor from space, I mean, with the exception of those things that you can't do from, you know, on the surface or below the atmosphere, ultimately what we really need are integrated observing systems, with a combination of space and surface base. We never want to, I think, create the situation of space versus in situ. That's a very unhealthy dynamic for us as a community to get into, and it's easy to fall into that, and we you know, want to resist that. I mean, there's no shortage of coordination mechanisms to do this. I mean, sometimes it's hard to keep track of all of them, and we're dealing with an increasing set of partners. You know, but there are certain things, you know, calibration and validation, traceable to recognized standards, data sharing, algorithm intercomparisons. There's a lot of things when one talks about working internationally across a number of providers. If you want to be able to integrate data sets, you got to understand a lot about the other data set. You just can't take one nation's data from their archive and another nation's data from another archive and mush them together and somehow you know, get an integrated data set. So there's a real research challenge associated with all of these things, and sometimes we tend to forget that. You know, it starts sounding so easy after a while because we go and look at all, you know, the images come out and everything looks so routine. But when you really talk about that integration, there will always be a research component associated with that.
Yeah, and I would agree, and I think you heard some of this. I mean, I think what we need to do is be a little bit smarter, and I think you heard it from everybody up here on the panel, and that is, we can't afford to go forward with observing systems that are uniquely done by one agency without crosscuts, and I think that's the real value of USGCRP now. You can't, from a modeling perspective, we can't afford to do that. From the service perspective, I think, again, it's the same issue. And I think there's recognition. I mean, our government is not set up to address problems that we have today that transcend all the agencies. And so it does make a real challenge for us to try to make sure that we're well coordinated. And I think, activities like USGCRP do offer the opportunity to try and work across the agencies to try to recognize that the questions we're having today aren't the same questions our fathers and grandfathers had, where you might go to a single agency and they could pretty much solve it. So I think these coordination pieces are going to be key.
Great, thanks.
I mean, I guess two quick things, sort of one more domestic and one more international. I think that really trying to make sure that the flow from research into operations and the coordination among research and operations is significant, so that, because in some cases we may have to slosh back and forth in terms of getting the data that we need. So domestically, I think making that link work, so that with the arrow pointing both ways, it's not just research to operations, it's research and operations working together. Internationally, I think a lot of it really is free and open data sharing, and that means not just sort of the retrieved geophysical products, but starting at the sort of lower level data in terms of calibration and validation. It's an increasingly international community, and I think there's real value added by people recognizing that, taking what they may perceive as some risks, putting their version 0 or version 1, not level, but I mean their initial versions, getting it out there, getting it utilized, making the investments in data systems that will allow people to use it, and recognizing that the more, when other people's eyes look at data, that's free help. May not always feel like it, but it absolutely is, and in the long run, I think, and that's how you really accelerate the benefit to that.
Thank you.
I'll just follow up on what Tom was saying, and actually what Tom and Jack said even before, is I think a way to get at that is to focus more on the coordination, specifically what Tom was talking about with USGCRP, but also what I was mentioning before, which would be an integrated strategy for Earth observations on a national level that basically coordinates not only the priorities from the scientific community and operational communities, but matches those with available budgets, and especially don't take on Earth observations from an ad hoc standpoint of, for example, some NASA missions that, as Jack said, are in their teenage years now, and you kind of wished you'd have, some are actually either close to or have reached the end of life that you wish had continuity. You'd rather not get into that situation and have some plan ahead, but you have to balance that with the resources that are available, as well as some flexibility to do new observations. So it really boils down to that coordination and developing a comprehensive strategy, which is something we're going to try to be working on this year.
Well, I guess I would answer with sort of a plea, both from the user's point of view and from Congress's point of view, that the USGCRP is all well and good, and it's important to coordinate the agencies. But ultimately, when somebody needs an answer, they're looking for, okay, where's the place that I go? And in our work with GAO on an adaptation report, that was kind of the continuing message of people who are trying to do adaptation work, is like, we don't know who to go ask. So I think, we do need to work on distilling this down to a sort of recognizable entity and one that users can interact with. to get what they're looking for. From the congressional perspective, you know, we're always eager to be able to exert our oversight authority, and so sometimes it's hard to get at that with GCRP because of its coordinating efforts. So you have, you know, the committees with jurisdiction over some of those agencies looking at what that agency is doing for the greater effort, and so it can be challenging to look at what it's finally done. But it's a great question, and one maybe you should put to the Washington Post reporters who just did that terrific article on sort of sussing out what's happened since 9/11 on all of our secret bodies and intelligence gathering. So they may be the best people to put on the job.
The only thing I'd say